Welcome, everybody. You are here for the Airbyte webinar, and we've been doing these monthly for a few months, generally themed around AI and LLM. Today, we have a topic for you, the ELTP data pipelines, and we're excited to talk through this with you. This is a follow-up to a recent blog post. My name is AJ, and I'm here with Joe, and we are the AI team at Airbyte. So without further ado, let's jump right in. Today we'll be covering a variety of topics from philosophical to practical, and hopefully there's something for everybody. There are a few different audiences we expect here today. Some people who are very experienced in ELT and ETL, and this P thing, this publish step, is the new thing. And some of you might be coming from the AI space where ETL and ELT are brand new terms, and you just want to build products that work and move data efficiently. So we'll try to speak to both of those groups and everything in between as well. So we'll talk about the evolution from ETL to ELTP. I'll share some common scenarios for the publish step and ELTP in general. We'll talk about the different ways you can adopt ELTP from wherever you are right now. After that, we'll jump into a demo, and we'll end with some discussion and Q&A. So as Chris, our media moderator for today's webinar, has put into the chat, you all can drop comments in the chat, and also we have a dedicated questions tab. If you have any questions, we will get to those based on where you when you end them. And Joe will be answering questions kind of asynchronously as I'm chatting, and we'll cover any unanswered questions at the end. So without further ado, let's jump in. So let's talk about the evolution of ETL to ELTP, starting with this acronym soup that we're dealing with. So to give a quick history lesson, ETL was the original term, and it generally involved a single tool that did all the things, and generally in a single step. So we'd extract data from whatever our raw data sources were. We would transform it, meaning we'd be applying cleansing rules, business logic, etc. And then finally, we would load the final product into a database or data warehouse for analysis. But there were a couple problems with that. Most important problem, well, two big problems. One is that they would fail a lot. If the data volumes grew, those transforms became fragile. And now all of a sudden we don't have any of the data from the source because it crashed halfway through. The other big problem is that our business logic would change over a few months or years. And when that transform step changed, it really would make this whole process essentially break. So what we evolved as the better process was extract, load, transform, with the priority on getting the raw data first, joining those EL steps together, and then transforming afterwards. So this is what Airbyte really excels at, is getting the extract and load as quickly and efficiently and robustly as possible, and then you can do anything you want in the transform step. What we're adding today is a publish step. So we're adding this publish step and helping you understand how you can get that transformed data into the destinations where it's needed, and some of the benefits of kind of decoupling the transform location from the final destination. So what that would look like in a diagram is simply, here's our data sources. We are extracting and loading them. We have custom transformations. And then finally, we are publishing to our downstream apps and consumers. So you can see this extract and load step and this publish step can be powered by Airbyte and or any other EL tool that can reach the sources and destinations that you're looking for. And then the transformations can be anything in the middle. So that's just a brief introduction to ELTP. And let's talk about some common scenarios in real world scenarios. So I already mentioned this in generic form. We're extracting, loading. I'm going to be using database or data lake kind of interchangeably. I'm not going to be too opinionated in this talk about where you want to put your data and where you want to transform your data. There are a lot of great tools out there. Some of our slides will mention like Snowflake or Redshift, for instance, but you can imagine Databricks in that spot, or S3, or wherever you'd like to put the data raw and then transformed. So just want to mention that. All right, so the first scenario is publishing to vector stores. And this is where a lot of people are entering the data engineering space for the first time. And if you have published to a vector store, then you probably know what RAG is, retrieval augmented generation. It's very common now in the days of GPT and AI to take some raw data. For instance, in this example, we have HubSpot data. We can extract and load that data into, for instance, Snowflake. We can transform that data and we can load that data into Pinecone. This is the ELTP model. I'll show you later on how you, maybe if you've not been introduced to ELTP, you might have done an extract and load directly from HubSpot to Pinecone. And that's what we call an ETL model, skipping this intermediate data store. Another common scenario is the SaaS application scenario. And this is where the term reverse ETL comes from. So if you've heard of reverse ETL, that's really a publish to a SaaS. Generally, we're talking about SaaS. So Salesforce, HubSpot, or any other API or service that you want to load your data into. Important for reverse ETL use cases is to consider that this area you have full control over. You can name it whatever you want. Once you push it into Salesforce, the upstream data source, you don't have much ability past that to transform it after it's landed in the source. So it's really important to get these transforms right and to be able to iterate on them quickly. Another common one is just publishing data files. You might have a partner who needs data in S3, or you might have to land data in SFTP for contractual obligations. And this publish model kind of gives you a nice framing to do that. In this case, we're using Postgres as an example for the database, but the scenario is the same. And if you guys do have questions, remember to drop them into the chat. Second to last scenario here, I think it's the fourth one, is publishing to BI tools. So you might want to publish data into a BI system so it doesn't have to go pull the data directly from your transformation database or your core databases. You might think that the more powerful Redshift databases or other powerful databases are also going to be fine to serve your BI queries, but they're generally not. For two reasons. One, these databases aren't always meant for high concurrency. And two, they're almost never designed for low latency. So low latency in a Redshift query would be like 10 seconds, 15 seconds. But the latency expectations for Tableau or other BI tools is like less than 5 seconds. So just completely different expectations. It makes sense to publish the data to these sources so they can give the best possible user experience. And then the last scenario is just publishing to other ELTP pipelines. A nice benefit of this model is you can chain them together. There's two reasons to do so. One, you might have a very complicated DAG or diagram, like you might have hundreds of steps in your transformations, and breaking it into smaller logical units just makes sense. That also gives you the ability to run those logical units at different cadences. Let's say this is my clickstream data. I have terabytes of data here. I only want to run this once a week. And these might be run once a day or maybe once per hour. So breaking them into separate processes gives you a little more control and a little more sanity. Another important reason to break these up is if you just have different teams managing them. A lot of companies have a central data team managing their core data warehouse. They might have a finance team that's managing the finance data mart, and they might have an analytics team or many analytics team consuming from both of the other teams. And so this model gives you a way to have clean delineation between responsibilities and to scale each one well. So moving on to the kind of practical, how do you get started? It's really not complicated, but I'll walk you through it just so that you can have confidence in steps forward. If you are starting from scratch, this is probably where you are if you're building an AI data pipeline, or if you've never built a data warehouse or data pipeline before. It's really just 3 steps, and you can guess what they are based on the acronym, or initialism, I should say, ELTP. Extract and load, that's basically setting up some connections here from raw data to your raw data landing zone. Transforming the data using a tool of your choice. I'm not going to be very opinionated on this, but of course, DBT is a very popular tool. For AI, there's also a tool called Kedro, and a lot of people just prefer Python scripts to do the transformation. This model can really support any kind of transformations you want to do. And then finally, publishing to your destination, creating that step to take your raw data and load it to whatever your downstream app or consumer is. If you're loading to a vector store, Airbyte has a bunch of, I think we have 4 or 5 now, vector store destinations you can choose from. And we'll talk about those in a bit. If you are coming from ETL, now here's the diagram I promised earlier on. If you're coming from ETL, and let's say this is your current usage, you're extracting from, let's say, HubSpot, you're loading. Let me see if I can make this a little bit bigger. Pardon my slide slippage. Looked like the font was getting stretched. Yeah, I'm trying to make the screen larger. Is that better, everyone? Can you see that a little better? Okay. So some people are mentioning, okay, yeah, it might be that the resolution is not coming through here. Yeah. Okay. Let's see if we've focused. 1 second while we see if, okay, it looks, some people are saying it looks good, and great. Okay. I did expand the resolution on my side, so hopefully that will help. And this is probably the smallest image we're going to have to look at, so hopefully it keeps it clear. Thanks to those in the chat who called that out. So yeah, just to call out, there's an extract from HubSpot in this example, but you could imagine this being Google Drive or PDFs, doing what we're calling a map transform, which means it's inline, text splitting and embedding, and then loading to Pinecone. Notice that there's no data store in this scenario. So if I want to change the transformation logic, or if I want to add additional transforms, I don't have a lot of options here. Secondly, so with this model, we just add this interim data store here. So we have HubSpot landing to a raw data zone instead of going straight to Pinecone. Now we can transform it however we want and publish. So the 3 steps are to add the load to a destination, transform the data if you need to do additional transforms, and then add an additional extract load step in this final step. So, and then the final evolution is actually pretty simple. If you already have ELT and you're just going from ELT to ELTP, all you need to do is add a step at the end to publish to the preferred destination. Okay, so now we are on to the section which will be the demo and tutorial. If you have, I see some people are commenting on the screen shares, and I think Chris is taking a look at that to see if we can tune that at all. I will keep moving forward. All right, so I'm using my favorite browser here, Arc browser. I am going to go first to Airbyte demo to show.
It's still sharing the presentation.
Oh, thank you for letting me know. It looks like I'm sharing a tab and not the window. Let me see if I can reshare. All right. So does this look good?
Yeah.
Great. Okay, I will boost the screen size a little bit more. All right, so I'm going to create to start off, I'm going to demo kind of the ETL mode, where I'm just going to get data from Google. Let me delete this real quick. Let's see. Start from scratch on this one. Okay, so we're going to do a new connection. So I'm here in the Airbyte UI. This is hosted by cloud.airbytes. You can also host yourself if you want to run on Kubernetes or with Docker Compose. I'm going to set up a new connection. In this example, I'm just going to pull from Google Drive. I'm going to, and I'll mention Google Drive is a brand new source for us. We're coming out, I think we were launching a blog post about that today. We now support unstructured, what am I missing here? Oh, so I should say, hold on. I meant to go sources. Here we go. So I'm creating a new source. And Google Drive is a new data source we are supporting. You can use it to extract kind of the traditional tabular data sources like CSVs, and you can also now use it to extract from documents. So I'm going to use my blog post drafts as a source here. I'm going to get the URL. I'm going to place that URL here under folder URL for this connection. I do notice that the example value is not exactly like what I've copy pasted. So I'm going to remove these extra characters. And this is going to allow me to take these documents and treat them as data. So these will be extracted and loaded into, I'm actually going to be using BigQuery for this example. So here we go. And I'm going to use OAuth to just quickly set up my connection to Google Drive. Great. So list of streams to sync. I've not yet set up any streams. Stream is just, you can think of it as like a logical table. And I have options for Avro, CSV, JSON-L, Parquet, and what I want is the document file types. Word wrap is going to be a little bit weird because I have the font size increased. Normally it won't cut off like that. And I'll call this drafts. Blog post drafts. Cool. So the rest of these I will leave as they are, and I'll go ahead and set up this source. So what Airbyte's doing right now is just testing my credentials, checking to see if that URL gets to a valid folder. It says all connection tests are passed. So here I am with my Google Drive source. It's prompting me to create a create a connection. And I will go ahead and create a connection. For this example, I'm going to create a connection to the Pinecone publish destination, which I've already created. I'll show you quickly what that looks like, but I won't recreate it in the interest of time. So what's happening right now is it's checking to see the schema of the Google Drive and pass that on to Pinecone. Should just take 1 second. All right. So here we are. In this case, I'm going to reduce the font slightly so it can fit on the screen. It gives me a default connection. I'll call this publish direct to Pinecone. Or actually, let me change. I keep saying pine code. I don't know why my fingers want to type that. So we'll call this ETL, direct to Pinecone. And I'm going to leave these as the defaults. Maybe I'll change this to append mode so it can do incremental. actually, it's missing a primary key, so I'm going to actually switch back to incremental append. So then I'll set that up. And that's all. That's as far as I'm going to go right now. I just wanted to demo for you the Google Drive to Pinecone publish. Now, Airbyte's going to automatically start syncing. One person in the chat asked to explain a little bit about Pinecone. Pinecone, you can think of it as a reverse ETL destination for vector indexes. Excuse me. Or you can think of it as a vector index. The reason that is valuable, vector stores and vector indexes are valuable, is that they are optimized for the kinds of questions that an AI will answer, that will ask. My question might later be, what did I say in my blog about ELTP? And the vector stores like Pinecone can find adjacencies and find similarities and find basically any reference to something that mentions ELTP and bring that back and give it to the AI as context. It'll say, please answer this question for the user. They asked about ELTP. Here's the context I found from the index. And then the AI can give a better answer because it has this complementary information. Hopefully that helps with your question. Yeah, and somebody else. I'm going to tackle the questions real quick before I move on. Is Firestore available as a source connector? I don't believe we have Firestore as a source. Joe, if you know otherwise, you can jump in. We can check. Great. Yeah, it looks like we do not have it as of yet, but there's an open request for that. And David asked, can ELTP pipelines be created and or run with Terraform provider? And yes, we actually have, with the quick start that will be launched next week, we're showing how to do this with the Terraform provider. And actually in my demo, I will show you the Terraform code. I'm not going to run it again in the interest of time, but yeah, all of what I'm doing right now can also be done in Terraform. I do see that I have an error here. I'm not going to go debug that. I will go check to see what the error is. It looks like I'm missing some configured fields, Notion text and URL. And that's because I've set up this destination for Notion. I'm going to keep moving though, because you'll see the demo for the other source I'm about to set up. So the other sources that we're going to use today is Notion. I'm going to actually pause for a second. Depending on the source data, you might have more or less need for transformation. Google Drive is an example of a source that actually, because of the features we've added and the way that we've built it into the source connector, we translate everything into Markdown so that what lands in your destination is text in Markdown. And for many use cases, that's going to be a lot easier to work with than the raw internal formats of, let's say, Google Drive or JSON-L or something like that. With Google Drive, you can probably land it directly into Pinecone without any issue. But Notion's an example of a data source that is not as easy to work with raw, and probably would not have good results if you tried to load it directly into Pinecone, or even just try to use the raw data without transformation. So when we go to our connections from Notion to BigQuery, you can see that Notion speaks the language of blocks, pages, and users. And that's not going to be terribly helpful for us when we're trying to merge that all back together. It's not really possible to do it inline. So we're going to use DBT to take blocks and pages and to merge them together. And to do that, I'm going to dive now into the code space. I'm using code spaces. GitHub code spaces allow us to open up a VS Code in the browser. and also to make sure there aren't any, it doesn't matter if you're running Mac or Windows or whatever, because it will be using the cloud for this. So I left mine idle for a while, so it's going to reboot real quick. And here's the data to Pinecone LLM quick start. Again, this is material. I want to say thanks to Chandler Prawl for creating this, and it will be coming out next week as a standalone quick start tutorial. Actually, before I go, so let's go to the DBT project. And what I need to do is I need to take the raw data that Notion is sending us, and I need to transform that into usable data for the LLM or for our own analysis. So here is a query that does that. And there's a quick explanation up top here. I'll increase the font size for everybody. So we're taking, this is just a query that does some Notion data transformation cleansing. Parent pages are recursively parsed downwards to locate all child nodes, and applicable node types are converted to plain text. So whether it's a header or whether it's bullets, it's just going to put into text. In the future, we could expand this query to also kind of markdownify the document metadata. This is helpful because LLMs do understand Markdown, and also humans can easily understand Markdown. For instance, a dash to indicate a bulleted list. These things are easy for both humans and AIs to read. So I'm not going to bore you with the details of this query, but just to share with you that it is a beast of a query. So we are recursively parsing through pages. This query is at work in its own. It's probably going to need to evolve over time. Like I mentioned, there's already a to-do on here to improve it. The nice thing about separating EL from the T and the publish is that we can iterate on this all day long and just republish. You never have to go back to our raw data store to get that data. So here I have at the end, a filter out of any null values, and I'm going to run a DBT transform real quick. If I can find my my quick cheat sheet here, 1 second. I don't want to be typing in everything in hand. Okay, so first I have a .env file here with some environment variables. There's a .env template, which shows you what environment variables you'll need. I'm going to source the environment variables with this little snippet, and then I should be able to run dbt run. So what I want to do is build, if you're new to DBT, it transforms SQL into tables. That's basically it. And it does it in a kind of a stateless way. You can see in this case, I'm just creating it as a view. So there actually doesn't need to be any data processed. I can toggle that to be created as a table without changing my original SQL file, just according to my performance needs. So at this point, what I did not show you is the actual connection for the data from Notion, which is our source here, to BigQuery. I'll show that now. So under connections, we have Notion to BigQuery. I did mention there's blocks and pages, and that's landing in the raw data destination that is BigQuery. So I kind of showed you this, but I didn't really walk through it. You can see that this has run. The job history will show that failed 2 times. The successful run took 20 minutes. So I'm grateful that I don't have to repeat that 20 minutes. My data is safely landed in BigQuery. Now I can go to BigQuery and confirm that, that everything is as it should be. If I go here to ELTP demo data set, I see here's my 3 raw data sets, pages, users, and this new view called Notion data. Notion data just outputs Notion text, URL, and last edit time. Nice and easy. So now I can go to Airbyte demo, and under connections. I've already created this new connection publish from BigQuery to Pinecone. This is that publish step we've been talking about. We're going to take a stream name of Notion, and we're just going to go ahead and run it. We've already run it before, but it won't hurt to run it again. And you can see under job history, previous syncs took about a minute. Yeah, so nice and easy to repeat. And that's 1 minute with this SQL, this table being represented basically as a view. This might speed up if we transform that into a table instead of a view. But for our purposes, 1 minute is really fast. It works fine as a view. We can keep it like that. All right, I'm going to check the chat before we go to the final part of the demo, which is the AI chatbot. And Joe, feel free to jump in if there's anything that needs to be addressed. I see there's a question about PG Vector. We do not yet support PG Vector, but that's definitely something we're interested in. And stay tuned or you reach out if that's something that you'd like to contribute to. I know that a lot of people are excited to use vector capabilities within Postgres, and that's a nice option.
There was also an interesting question about how structured data works with vector databases. So in general, Airbyte does not have a notion of structured versus unstructured. All the data coming from sources is records, and a record is a piece of data which has multiple fields, which all have a certain type. In case of structured data, you normally have a lot of fields, and they have all specified types like string and number and boolean and so on. Unstructured data is more like you have one field and it's just a large string. It's just a lot of text all in one blob, and there's no further structure to it. For the destination, this doesn't matter. As AJ is showing here, you can select which fields to store as metadata because you want to filter on it structurally, and you can select which fields are text fields, and those are the ones that will get embedded and make up the embedding vector of that record.
Yeah. Yeah, exactly. And I want to, Joe's been the major developer on these vector store destinations. So hats off to him for designing this in a very usable, user-friendly way. I do want to call attention that this is no code. You just specify which fields should go into metadata, which code should be text fields. And also text splitting can just be defined here without writing any code. You can also pick your preferred index names, and then whether you want to embed with OpenAI, Cohere, Fake, Azure, etc. So if you have been through this exercise before and you know what all those words mean, then you're probably happy that they're there. If you have never built an LLM pipeline before and you're new to vector stores, just know that this makes it really easy. You don't have to go figure out a new Python library. You can just type in kind of the configuration you want to try. And then the other important thing here is that note that if I want to change anything here, I don't have to re-extract data from Notion. I just change what I want to change. In this case, removing URL from the text to embeds or changing chunk overlap to 32. And then I'm just going to rerun this final step of the process. I don't have to change any other part of it. I don't have to rerun any other part of it. And that's really important and powerful. I can also, for experimenting, I can just duplicate this destination or this connection and sync it in a few different ways. Like try once with URL and without URL, see which one gives me better results. Or try with bigger chunk overlap or no chunk overlap. This is really great for experimentation and iteration. But without further ado, I want to get over to the final part of the demo. And the final part of the demo is that I want to ask some questions. Actually, no, before we get asked questions, I did promise I'd show you the Terraform code. So here is the Terraform code. Under Infra Airbyte, you can see, for those of you who are interested in Terraform, we are deploying source BigQuery as a resource. This is backed by the Airbyte provider. And for Airbyte Cloud, all you need is a bearer auth token to authenticate. I won't spend too much time in the Terraform because, again, we only have so much time to go through. But this will be coming out next week, and we hope you'll kick the tires and tell us what you think. So now back to the AI part. So we're using LangChain in this example. I'm also using a library called Rich. If you've not used Rich before, and if you are a Python developer, definitely check out Rich. It's great for rendering rich text, which you'll see in the demo. Here is just a prompt template. I'm telling the AI what I want it to do. You are a question answering bot. The use case I should have mentioned earlier that we're solving for here, and maybe you guys can relate. Within your company, there might be tons of internal intranet or handbook pages or content that is available for employees, and you want to be able to quickly ask questions of those resources and get a good answer back. We are actually dogfooding this right now with a tentative plan to put it into Slack as a Slack bot for us internally. So you might feel inspired, and if so, great. Things like this often are helpful for LLMs. Do not guess, do not use prior knowledge. I don't want Airbyte. I don't want the LLM to, based on what it knew about Airbyte 2 years ago, to try to guess the answer to these questions. I also provide this. Provide your answer in Markdown format, starting with a level 2 header. You'll see why that's kind of cool in a second. So here it is. Nothing fancy, less than 100 lines of code, and a big bulk of that is just us typing in human language what we want the AI to do. So I will expand here again my my terminal, and I think what I need to do is source benv in Python. Is that right? Hold on. Let me get my cheat sheet.
I think it's activate instead of Python.
Okay. Yeah, there we go. Thank you. There we go. Thank you. All right. So now we're in our Python. We've just in this. The reason I did that is because this has the necessary pieces installed, and I'm going to run query.py or maybe Python. So what this should do is it should ask me for some questions. What do I want to know? So the first question, everyone, of course, asks when they start a new company, what is the PTO policy, right? That's what everyone asks. No, you don't ask that because you probably know it before you joined, but I'm trying to be funny and relatable. So this took a little bit of time to just initialize. The next calls will be faster. Note how readable this is, even though we're in the terminal. Telling the AI to print Markdown and also using the Rich library to render the Markdown is just really nice. So Airbyte provides unlimited paid off for all employees, the approval process, very cool. If I'm not sure this is accurate, I did test this ahead of time. I do know it's accurate, but we're getting the links also to those pages, so I can click to see, great, paid time off. I've been very careful to curate like what I'm able to share here. This is live, so I could make an oops, but I did test these out, and our paid time off policy is public, so not a surprise. But anyway, so yeah, you can see these basically being answered by the data that we put into the vector store. So the vector store took our entire Notion intranet websites, and then when it asks this question, it finds all the relevant pages and then gives the links. What else do I want to know? Who is in the language models team? And it looks like we have a TBH software engineer. So if anybody's looking, we have, oh, this is not a good answer. Okay, this is not a good answer, but this is where our strategy of linking to the source material really pays off. Because if I do get a bad answer, I can come over here and I can just see the actual page and figure out what the right answer is. Let's try again. What does the AI language models team do? So, and we should get a response here. Yeah, handling of text document stores, vector store destinations. Yeah, so all this is good stuff. Another one is, where can I find the 2023 goals? Hopefully this is giving you guys some ideas. We've all been kind of floored by how valuable this actually was, not just as a proof of concept, but we're excited to like actually deploy this on site in something like a Slack bot. So yeah, whatever you could lose. These are kind of those dumb questions where you don't necessarily want to bother somebody with them, but you also want to spend 20 minutes looking. I'm going to pause real quick. We can keep doing question and answer, but I'm going to check the chat for any unanswered questions and comments.
There's one you have to answer. What browser is this?
Oh yeah, this is Arc browser. I love using it for demos because it's nice and clean. And I can rename tabs. Yeah. All right. How did you get Rich to do that in the terminal? Yeah. So this is one really nice feature of Rich is that you can just do console print, tell it you want this is Markdown, and it will render it as Markdown and print it as Markdown. Internally, how does this work? I do not know, but it is just using Bash, and apparently these things are supported. Yeah, it's been quite a nice experience, and I've used it on a couple other projects as well. So I've had a good experience with the Rich library. Somebody asked if the code is up on GitHub. It is, but it's under a PR right now. So that PR is not merged, and we will be merging that shortly. It's in the Quick Starts PR if you want to go to Airbyte HQ/Quick Starts on GitHub, and then just kind of browse around at the PRs, you'll find them. So yeah, let me see other questions. Cool. All right. Well, I think that mostly completes the demo. I'm trying to think if there's anything else that I really wanted to show off today. Let me see. Yeah, I think that basically covers it. We could keep asking questions. I promise you, they're all almost all the answers are good. And this line, I highly recommend if you are training in an AI to do these kinds of questions. Where is it? Right here. Make sure you include these kinds of instructions along with the links to those relevant pages, because it's great to get an answer. It's even better to have confidence the answer is right, because you can just verify yourself. And I'm really happy with how this worked. The first time I created it, the URL was in the metadata, but not the text. And the AI just wasn't very good at accessing it. So I ended up putting the URL and the text into the same kind of text field. And that just made it brilliant. All right, I'm going to end my, actually, no, I'm not going to end my screen share. I'm going to keep screen sharing, but I'm going to hand off to Joe to talk about some of the Airbyte capabilities that are behind the demo today.
Sure. Yeah. So thanks, AJ, for walking through this in the demo and explaining the idea behind this, which is just really a blueprint for how to architecture your data pipelines. And so what can Airbyte specifically bring here? Airbyte is not doing this whole pipeline you've just seen. This is an important thing to emphasize. Airbyte is moving data from A to B. So if you have data in one place and you want to get it to another place, this is the part Airbyte takes care of. So it's doing the extract and the load of the whole ELTP thing. And especially this initial extract from the raw source is what Airbyte is really good at. So we have tons of sources, and we invest a lot of into building a system where you can add new sources very quickly and easily by having shared abstractions and shared code you can reuse. And there's also lots of destinations like warehouses and databases where this data can be moved to, but it's always a connection is extracting the data somewhere and then loading it somewhere. And then the transformation part is is happening within their destination, and it's not the job Airbyte is taking care of. When you want to run Airbyte, there's multiple ways to do this. So essentially, Airbyte is a bunch of Docker images you need to run in somewhere. So you can do this via Docker Compose. You can run it in your own Kubernetes cluster, or you can use the fully managed cloud service, which is essentially the same functionality, but there's also support and all of these things. Along with the sources we do have, it's also possible to build your own connectors, because especially if you get deeper into this, there will always be things like services or something where you want to extract data from, which is not supported by Airbyte today, because there's just an infinitely long tail of APIs and weird storage formats and everything. But you can build your own connectors. As I mentioned, it's all Docker images, so you can build your own Docker images for specific sources and for the basic cases, like REST APIs, which are the most common subgroup of sources. There's also a UI to configure them really quickly in the browser. But related to the demo HH just showed, I want to get a little deeper into new kinds of sources and destinations we are currently working on, especially around language model use cases. So first are the vector store destinations. The Pinecone one we've just seen is one of them. This is, it's a destination we load data to, but it's really one of the published destinations, in the sense that you publish the data somewhere where it's actually queried by an application, like the Python script HA showed. And the current state there is that we are supporting most commonly used standalone vector databases, Pinecone, Chroma, BB8, Milvus, and Quadrant. And this destination is taking care of the chunking and the embedding as well. So it's doing a little bit of transformation, but not just on a per record basis, to prepare the data to be able to be moved into a vector database, because vector databases always expect like a set of metadata fields. They expect the text this record is about, and then they expect the vector for the vector search. And this is what these destinations are doing. Important to note here is that all the Airbyte pipelines, not all of them, but most of them can run incrementally, which means you won't reprocess all of your data over and over again when something changes in the source. You can only process the delta, and especially the vector store destinations have functionality built in, so it will make sure to kick out the old vectors, which are stale now because the records changed, and update them with the new ones. So your cleaned data set in your warehouse is always in sync with what's in the vector store. Next slide, please. On the other side, like really early in the extract phase, what we recently added is the ability to fetch data from documents. So in the demo HA showed, we got the data from Notion, which is an API, but it could also be called a semi-structured data format. This is very helpful for a lot of cases, but what's a pretty big one, a pretty big use case, which we didn't support up until very recently, is just file storages, which have PDFs and Word documents and Google Docs and so on lying around. And these can now be extracted as well using the Google Drive S3 and also very soon SharePoint OneDrive connectors. So what's happening here is that the connector is loading those binary files and then extracting the raw text out of it, and the record that gets sent downstream to the destination, for example, a vector store, is just the text content. So it's not the full file, but the text content of the file. The connector is taking care of that as part of the extract. So it's, as you can see, it can centralize all your data in a form that the language model can understand.
Thanks, Joe. And I think that gets us to final Q&A. We went a little bit over the time. Hopefully that was fine with everybody. I see we still have tons of people still in the room. Last chance for questions, I guess. I saw some questions which I answered directly in the chat. And I think we've covered most of the ones that need to be called out live. So I think at this point, we'll go ahead and say thank you for joining us today. And we hope that you will try out these tools. We hope the ELTP framing architecture has been helpful to you. And We will see you at the next webinar. We've been doing these monthly. Also want to call out Airbyte's Move Data Conference is coming soon. So check the website for details. There's going to be a lot of great presentations from people throughout the industry, including Joe. We'll also be doing a talk at Move Data. And yeah, Joe just put it into the chat link if you want to click directly there. Thanks, everybody. Have a wonderful day, and we'll hopefully see you soon. Bye.
Bye.